try. At least for the time being. Mashroor is coming, Aisha is coming. Aisha already joined. Hello, Aisha.
Assalamu alaikum, sir.
Walaikum salam. Today there is some problem with network from my side. So it was late to join the class, and also there is some problem to show you the files from the screen. However, we are trying, and we will continue in alternative ways as much as possible.
Should I share my screen because I have it in front of me?
Okay, you can share.
Yeah, if you make me the co-host. Or else it's
Co-host, how to make it
that I have no idea.
more in show names of hide, floating, meeting, controls, pause, recording. Okay, co-host. I don't see where to make co-host. How? Okay, we will in security. Can you see it in security? Share screen. Okay, this one I gave it. Allow participants to share screen. In security, I gave it. I got it. In security
Yes,
part,
sir.
it's available. So now you can share. You just open the notes.
Yes, sir, but you
First.
have to stop screen sharing before that.
Okay, I am stopping that one. Is it now okay? Check.
Is this okay? I don't know.
Okay, thank you. Thank you so much. I can see it.
Assalamu alaikum, sir.
Walaikum salam wa rahmatullahi wa barakatuh. How are you, Yakin?
Sir, I'm fine, alhamdulillah.
Today, with your help, we are continuing the class. From my side, we have some network issues. So I need
Yes,
your
sir.
cooperation. Already Ziba is helping me by sharing the screen. So we did till the half-life in last class, right?
Yes, sir.
Up to here.
Yeah, and today, if you have seen the Google Classroom meeting invitation, there I mentioned we are going to discuss the hazards or the
Yes, sir.
problems.
Worksheets.
Yeah, problems we are facing. And the worksheet will be discussed in the second class. In the first class, we are having the hazards. That means problems or the difficulties we are facing while we are dealing with the radioactivity, and how to minimize them, how to avoid them. Those we will discuss. Go a little bit down, Ziba. Then after that we will have discussion on background radiation. Background radiation, and finally we have the discussion on carbon dating. So the first one is radioactivity hazards. We are going to discuss then the effects of radiation on the human body. Actually, radiation has the effects on all the animals, not only human body, on the plants also, in the sea creatures, everywhere. It has a bad effect, and directly
Then
or
topsoil too.
yeah, in directly or indirectly, it's actually making problem with humans. Like some years back, there was an accident with Fukushima nuclear power plant. It is very close to Pacific Ocean, and when the radioactivity was going to the ocean, then those were risk, because people are fishing over there, right? and they are taking lots of food from the sea, and the seawater is going to in different places. So that was a big problem, that radioactivity can transfer or travel in many ways, and they can be going into the human bodies. Okay, and once it is going to human body, you know that their half life is very long. Radioactive elements, it will work generation after generation. Like you are having radioactivity, maybe your grandchild and grandchild, they also have this effect in their body. That's why radioactive hazards we should avoid. So I want Yakin to read radioactive materials are hazardous from here.
The effect of radiation on the human body. Radioactive materials are hazardous. Nuclear radiation can ionize atoms and molecules in the body, which may change the way cells behave. It also transfers large amount of energy into the body, which can damage or destroy cells. Effects that radiation has on a human body include eye cataracts, cancer, skin burn, leukemia, and other blood disorders.
Yeah, now
Man-
how to solve this problem or how to manage these problems? Yeah, continue.
Managing the risk. The risk associated with radioactive material depends on the amount and type of radiation. For example, alpha radiation is more ionizing than gamma radiation, but does not penetrate as far. In general, the dose received and the risk of ill effects increased by being exposed to highly reactive metal to radioactive material for long period of time on a regular basis.
Okay, so from this part, I think all of you understood, right? You have any queries in this part till managing the risk? Moshe,
Yes, sir.
anyone has any problems? Aisha?
No, sir. No.
Okay,
No,
so
sir.
we can continue in the precautions, right? Yeah, continue in precautions. Jiva, go down.
Precautions are take
Jiva, go down.
so
I can't see precautions.
so we can see it.
Yeah, okay, okay. If you
Yes,
can
sir. We
see,
can
then
see it.
continue then. Yeah.
Precautions are taken to reduce the risk of harm when using radioactive sources. These include keeping radioactive sources shielded when not in use, for example, in a lead-lined box, wearing protective clothing to prevent the body becoming contaminated, limiting exposure time so less time is spent with radioactive material, handling radioactive material with tongs to increase the distance from them, monitoring exposure using detector badges.
So all these are clear to you?
Yes, sir.
Yeah. So these are the steps or the measures we can take to reduce the risk or to avoid the radioactivity, right? As much as
Yes,
possible,
sir.
we will try, but 100% you cannot avoid if you are very close to radioactive source. So these are the measures you have to memorize. Yeah, all these points. In some of the questions is structured part, we are sometimes getting these questions. And how to reduce the risk or how to avoid radioactivity, which measures should be taken. So you should memorize all these 5 points.
So there should be a real life measure taken. মানে আমরা যখন হসপিটালে ওয়ার্ডে থাকি
Mm-hmm.
অথবা মনে করেন ক্যাবিনে থাকি তখন যে পোর্টেবল এক্স-রে মেশিনটা নিয়ে এসে এক্স-রে করে,
Mm-hmm.
তো ওই রেডিওলজিস্ট আর পেশেন্ট ছাড়া রুমে কারো থাকা উচিত না,
Mm-hmm. Right, right.
বিকজ ইট কজেস রেডিয়েশন।
And they are doing it. When I visited some of the hospitals, that time they did so. Like I brought my grandfather. Then during the extra time, I was requested by the radiologist to go out, to stay out.
Oh,
So they are doing it.
no, no, sir. I'm talking about the portable one.
Yeah, portable one also the same thing. Okay,
Oh,
okay. Portable was also is also like that one, right? It has some
yes,
effects.
sir.
So as much as possible, we should avoid this one. Okay,
Yes,
because
sir.
X-ray they have also very much high frequency and high penetrating power, so they can also damage the cells. Even some of the X-rays they can cause cancer. If you are taking too much X-rays, then there will be cancer also, right? So we should avoid that one as much as possible. We should avoid them. Okay, then background radiation. Before going to background radiation, I want to bring some experience from my life, my student life, when we were doing the experiment with the radioactive sources. Uh, we had Geiger-Müller counter, and we had the meter over there to see the readings. And uh, even after we are not giving any source in front of the Geiger-Müller tube, we still got some readings like 10, um 10 readings per minute, or or 20 readings per minute. Okay, we are getting over there. So from where we are getting these readings, though we did not give any radioactive source, however we are getting some readings. That is the proof that we even after we are not giving the radioactive source, some radioactivity is available in the surrounding area. Uh, those readings are coming in the Geiger-Müller tube, and we can see those readings. That is called background radiation. Okay, without the source, without the radioactive material, the count rate or the reading we are getting in the counter detectors, those are called background radiation. Okay, without the source, for example, we are getting 10, 10 counts per minute. Then with the source we are getting 1010 per minute, the counts per minute. So we are subtracting that 10 from 1010, we are getting 1000, right? As our real counting, or the counting from the source. Do you understand what I am saying about background radiation and how to do the calculation with the background radiation?
স্যার আরেকবার একটু
Yes,
বলবেন
sir.
বুঝেছি স্যার
Okay, should I tell you again?
ইয়েস স্যার
Okay, listen. When we got the reading without the source, like I'm as I'm not sharing the screen, can I draw? Is it possible for me to draw?
Yes, sir.
Hmm?
Yes, sir, you can draw. The annotations are on.
Annotations are on, so where it is?
স্যার নিচে দেখেন লেফট সাইডে
Security.
A pen type of thing should be there. A drawing of a pen.
Okay, fine. You try to understand that if we are giving any Geiger-Müller tube here, and there is no source in front of it, that time without the source we are getting some readings in the Geiger-Müller counter. So without the source, in theoretical point of view, there should be no reading, right, Moshi?
ইয়েস স্যার
Okay, so, even after that we are getting some readings. From where this reading is coming? It's coming from the surrounding area, like we have cosmic rays, we have food and drink, even our body, the wood, they have some carbon 14, right? Uh,
Yes, sir.
you know
Carbon
that
14.
in our body there is maximum part is hydrocarbons, organic material, right? You know about organic chemistry.
Yes, sir.
So in organic chemistry you might get this idea that you have you know CH4, then you have CH3OH. All these are hydrocarbons, right? Ethanol, methanol, then ethers, then methane gas, uh, then propane, ethylene. All these are hydrocarbon. They all are made from carbon and hydrogen. That's why they are called hydrocarbon. In our body also, all the living things maximum they have made from the hydrocarbons. So in hydrocarbon sample, all the hydrocarbon samples, there is some ratio of carbon 14. Along with carbon 12, we have also carbon 14, and you know carbon 14 is radioactive, isn't it? Hello.
Yes.
Yes.
That's why you see there, you see here buildings and the ground, then food and drink, even from the surroundings area, everywhere from there is little bit radiation is coming. Yeah. And this radiation is giving any some counts in the Geiger-Müller tube. That one we are getting even without the source. So this radiation or the counting we are getting without the source, it is called background radiation. Is it clear now?
Yes.
Yes, sir.
Okay, so how
Excuse
we
me,
are?
sir.
Yes, please.
So can I just cut in for a bit? Now that you've given us information sheets, like from, well, you've given us information sheets, right?
Mm-hmm.
Do you have all of them,
All of
like
them
on
means what?
radioactivity and like nuclear atom and the
Mm-hmm.
ones in the previous session?
Mm-hmm.
Can you
So
just
you
send
need
me all of them in Messenger?
you need notes on radioactivity and the
Uh,
nuclear atom. These two only, or you
I
need?
already have no. I have
Okay. So you want
radioactivity. I
you
need a
you
nuclear atom and
and
the previous ones.
okay.
No,
I
not there anymore.
okay. No problem. No problem. I will give you. I will send you them through your email. Okay, that will be better.
Okay, yeah.
Okay, I will send you.
Thank
No
you,
problem.
sir.
I understood that you want the notes on all the topics, right? All the
Yes,
Cambridge topics,
yes,
right? And
yes,
that is helpful for you, right? To go through.
yes, sir.
Okay, no problem.
Thank
I
you
will
very
give
much.
you, inshallah. I already gave on in your school time classes I was taking. That time I gave you some notes on light, right? Those
Yeah,
hard copy are available with you, right?
they should
The
be, yes.
waves on waves and light. I gave you some notes, and I also gave some notes on electricity part, right?
Yes,
Okay. So that one I gave you during the final term, current electricity, DC circuits, then
yeah, I
practical
don't have that
electricity.
one.
Okay, those,
That one,
yeah, I will give you, no problem. No problem, I will give you. Don't worry. Now, look, the background radiation, I think you already understood, right? Hello?
Yes, sir.
So now we are going through what is written over here in the notes. Then you will understand more, inshallah, and more specific it will be. Then Ziba, you read. Ziba, you read.
background and radiation. Radioactive materials occur naturally As a result, everyone is exposed to low levels of radiation every day. This exposure comes from a mixture of natural and man-made sources. Pie chart looking at sources of background radiation. These are from random gas, buildings, cosmic rays, food and drink, and man-made. Man-made is broken down in another pie chart.
Yeah, go down, then we'll get it. Yeah,
The actual amount
see the sources from the diagram. See the sources, and here we have two pie charts. The upper one is from natural sources, and the lower one is man-made sources. So from all these sources, we are getting a little bit background radiation. Okay, so go down then.
The actual amount of radiation that a person is exposed to depends on where they live, what job they do, and many other things. Scientists must always take into consideration the amount of background radiation when working or experimenting with radioactive sources and discount it from their results.
So this one is clear to you, right? I
Yes, sir.
gave you one example that without source, for example, you are getting 10 counts per minute. If you count with the source, it is coming. Source means any uranium sample you are giving in front of it, or any cesium sample you are giving in front of your Geiger-Müller tube. Then you are getting the alpha, beta, and gamma radiations, and those readings are counted in the Geiger-Müller meter. So that one you are getting with the source or with the sample. For example, you are getting 1010, and your background radiation was 10 only. So you can subtract 1010 minus 10 equals 1000. It is your real or the counting you are getting from the source. Is it clear, everyone? How to calculate with background radiation? Okay. Now we are going.
Yes.
Yeah. Now we are going with carbon dating. Okay. Already I told you some ideas I gave you that all the living animals, they have carbon 14 sample in their body, and because of this uh, we we are having some radioactivity from the samples, and we can detect it how much years or how many years before the living things were available in our earth. Like nowadays the archaeologists, they are finding the fossils of different animals or different plants, ancient animals, ancient plants. After getting those samples, uh, by carbon dating, they can find the years, how many years back those were available on earth. Okay, so this process of using carbon 14 half-life to get the age of anything, uh, age of any fossils, this process is called carbon dating. So we are going to have more discussion. You see in the right side we have more discussion. You check the diagram also while you are reading. You also check the diagram, then you'll understand it more. So I want Aisha, please read it. Aisha, right side.
Okay. This is how this is how carbon dating works. Carbon is a naturally abundant element found in the atmosphere, in the earth, in oceans, and in every living creature. C12 is by far the most common isotope. While only about 1 in a trillion carbon atoms is C14, C14 is produced in the upper atmosphere when nitrogen 14, N14, is altered through the effects of cosmic radiation bombardment. A proton reacts with a neutron, effectively changing the nitrogen atom into a carbon isotope. The new isotope is called radiocarbon because it is radioactive. So it is not dangerous. It's naturally unstable, and so it will spontaneously decay back into N14 after a
Assalamualaikum,
period of
sir.
time.
Walaikum salam. Thank you, Adnan, for joining, though it's late. So continue your reading, please. Go down and continue.
Ziba.
Go down, please. We will
It
come
takes
back here.
about five.
Yeah.
It takes
Yeah.
about 5,730 years for half of a sample of radiocarbon to decay back into nitrogen. It takes another 5,730 for half of the remainder to decay, and then another 5,730 for half of what's left and to decay, and so on. The period of time that takes for half of a sample to decay is called half-life. Radiocarbon oxidizes, that is, it combines with oxygen. It enters the biosphere through natural processes like breathing and eating. Plants and animals naturally incorporate both abundant C12 isotope and the much rarer radiocarbon isotope into their tissues, and with the same proportions as the two occur in the atmosphere during their lifetimes.
Okay. So here, wait here. Huh? We are understanding from this example that half-life of carbon-14 is 5730 years. Okay, and we are having this sample. For example, this one. This is one of the fossils. Wood. This one is giving us the idea how we are using the carbon dating process. Look, for example, the archaeologist got it, and the archaeologist, they have the information that if the wooden piece of uh, wood is 5 kg, for example, it is 5 kg, then how much carbon-14 should be there? There should be 2 grams or 3 grams of carbon-14. Okay, and from that 2 grams or 3 grams carbon-14, then there might be, I'm giving you some examples only. It's not exactly that in 5 kilogram there will be 2 grams or 3 grams carbon-14. Just for example, to make you understand. So if the archaeologist find that here we are having the counting rate in the Geiger-Müller tube or any other meter. Now we have much more modern detectors we have. So from the 2 or 3 grams carbon 14, there is one standard to get the, like there might be 5,000 count. If it is at the beginning, there should be 500 counts per minute. That should be the standard, right? From 2 or 3 grams carbon-14. But the archaeologist, he is now finding only 50 counts per minute. So from this information, he was supposed to get 500. Now actually he is getting 50 now. So from this information, he can understand that how many half-lives already crossed. Can you tell me how many half-lives crossed over there? The reading should be 500 at the beginning. Whatever the sample is available of carbon-14 in the given wood, but now he is getting the count rate only 50. So how many half-lives were gone? Can anyone tell me?
10.
Can you check out this way? Like 500 is half is 250, right?
250, yes.
Then 250 is half how much? 125.
125. 125.
And then 125's half is
6.5.
120.
62.5.
Yeah, 62.5. Then 62.5 its half is
31.125.
31 point কিছু একটা কিছু জানি
okay.
না।
0625.
So how many
3.5.
half-lives you got to come here in 31?
4.
4
Four half-lives you got. So our reading 50 counts is between 31 and 62, right?
Yes,
Isn't
sir.
it? So we can think that it's going 3 half-life and half after that more half, right? Half of the half-life. So 3.5 we can say. So if the half-life of carbon 14 is 5730, you can multiply with 3.5, right, to get the years, how many years back the wood was available on earth. Is it clear?
Yes, sir.
Is it clear, everyone?
ইয়া কিন্তু তোর ফোন
হ্যাঁ, আমার ফোন।
Is it
এত আওয়াজ কার ফোনে
আর
করতেছে
ফোনে
ভাই, কানটা ফাইটা
নোটিফিকেশন
যেতেছে
অন করা না, নোটিফিকেশন অফ করে
ভাই,
দে।
কানটা গেছে।
okay?
আমার
Is it
মিউট করা ছিল এতক্ষণ, আমার না।
নোটিফিকেশন অফ করে রাখ।
okay? Is it clear
আমার
to
তো
everyone?
মেসেজই নাই। Yes, sir. It is.
It is clear. So how we are doing carbon dating, it's clear to all of you, right? And Adnan, you joined late. You got
Record.
the idea, right? You got
আল্লাহ,
the idea. Whatever we discussed, at least the last part you understood, right? And previously also we discussed some of the things, background radiation, and
Sir,
we discussed a little bit of half-life. Yes, tell me, please.
explain how carbon dating works again and how it works.
Sorry, again, please.
How it works. Can you explain that again?
Yeah, I am explaining again, no problem. I told
আই
you
ডু আই
that
ফিল লাইক এটা শাহজাহান স্যারের স্ক্রিন না?
it's Ziva's screen. Because of some network problem, she is helping me. Okay, so I am repeating, huh, Aisha? Inshallah, you will understand. Look, this wooden sample, I gave you one information that, for example, this wooden sample, the archaeologist got, for example, it is 5 kg. Okay. Hello.
বলেন স্যার, শুনতেছি।
Hello. Then after getting this information, the archaeologist will have some information, like he has the idea that this 5 kg sample of wood have 3 grams of carbon 14. Till here you understood? Hello.
Sir, will he take the compound then ওই যে আমরা যে percentage composition বের করি কেমিস্ট্রিতে ওইভাবে করবে?
Like that, like this 5 kg wood, it might have, for example, 1 kg or maybe 2 kgs of carbon 12, right? Isn't it?
Yes, sir.
So
Yes,
out
sir.
of this carbon 12, there might be 3 gram or 5 gram carbon 14 also, right? Because carbon 14
Yes,
is
sir.
a small amount, right?
Yes, sir.
Isn't it? So that from that sample, they have also the standard that how much reading will be coming in the Geiger-Müller counter from that sample, carbon 14. I gave you just one example for your understanding. I gave one round figure, like I gave 500, right? And now I am making it more simpler for you. For example, the count rate should be 400. Okay, so that your ratio is coming, nicely. Is it okay, Aisha?
স্যার
Is it okay, Aisha? Hello, Aisha.
Yes, sir. Thank you.
So at the beginning, the count rate should be,
স্যার 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 স্যার
yes, tell me.
স্যার এই মিটিং যে কোনো টাইমে বন্ধ হয়ে যেতে পারে স্যার।
Yeah, I know, there is
একবার
5
জয়েন করি
minutes.
স্যার।
There is 5 minutes. Okay. After
আচ্ছা স্যার।
5 minutes, it will be over. and then we will start the new meeting. Okay, the same ID, same password. Okay, so what we were saying that at the beginning it should be 400 counts, right, Aisha?
Yep.
Hello. So the count meter or the Geiger-Müller tube should give you the reading of 400, but we are getting the reading only 50. How much we are getting? Hello,
50.
50. So it shows in theoretical value it should be 400, but we are getting 50. That proves that this wooden sample is not from recent years. It's from long back, right? And that one we have to measure from this count rate. So our standard should be 400, but now we are getting 50. There might be some half-lives gone, right? That's why we are getting 50, isn't it?
Yep.
Hello, Aisha.
3 half-lives gone.
Yeah, 3 half-lives or 4 half-lives we will count and we will get it. Like 400 to 200, then 200 to 100, then 100. Yeah, 3 half-lives. So 3 half-lives, 1 half-life is 5730 years. Then if you multiply with 3, then how many years coming? It's around 18,000 years, right?
Right.
Yeah. So we can understand from this information that this wooden piece was 18,000 years back. It was available on Earth, right?
Right.
So this way we are having the carbon dating not only for these plants, wood, we are also having for animal fossils, right? Like dinosaurs, they were on this earth many years back, like millions of years back, right? And there are different kinds of dinosaurs. So this way the carbon dating is helping the archaeologist and also helping us to understand the history of Earth, right? History of the globe. So is it clear, everyone? Carbon dating.
Yes, sir.
Okay.
Yes, sir.
Now, can you go down little bit, Ziva? Little bit down. We are having 2 minutes. Yeah, go down, down. Yeah, we are at the end of the notes. Yeah, go down. Mhm. Yeah. So here we are seeing with the graph that how carbon dating is working. Yeah. The same thing we discussed. That one is
Sir,
here. Yeah. Yeah. Tell me.
sir, is it only for carbon 14's half-life is 5,730
Yes.
years?
Yes. 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 You know.
Different element have different years.
Yes. Different element has different years. Some of the elements they have only few seconds. Some of the elements they have a few days. Some of the elements they have few years. Okay, some of the elements they have few hours. So it
আচ্ছা,
depends.
কার্বন ডেটিং দিয়ে তো সবকিছু করা যায় না, তাহলে বাকিগুলো কি দিয়ে করে?
Carbon dating is used for fossils years. We are using carbon dating
না,
because
অনেক কিছু আছে তো আরো পুরানো, বা দেখা যায় অনেক কিছু সাবস্টেন্স আছে তো যেগুলো
whatever
কার্বন ডেট করলেও
whatever
কিছু হয় না।
Chromatography দিয়ে করে।
Oh, that makes sense. Thank you.
yeah. So all the samples actually whatever we are getting, any animals or plants, the living things, they have some carbon 14. Okay, because they are made from hydrocarbon. Is it clear?
Yes,
Hello?
sir.
Yes, sir.
Yes, sir.
Okay, so whatever we discussed just now, that one is described here. Okay, the discussion we had just now, all these things is discussed here. So we will continue it in next class. Okay, thank you so much.
Sir,
Thank you.
আল্লাহ হাফেজ স্যার।
join
Join after 5 minutes.
আবার
After 5 minutes you join. Okay.
আল্লাহ।
ওই তো স্যার